what I'm going to do today is I'm going to try to get that running, see what happens. Now, I am going to warn you. I haven't been touching code for a while, so I'm not. That's not what I do on a daily basis. So some cringe might be coming in this video, but I think that's going to be a good learning experience for both. Actually, maybe it's just for me. What I did do is I did install Peep. I'm on a virtual machine with Ubuntu. I think I'm like on the LTS version 18 point something. Um, mm, 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 mm. Here they do say that it's recommended to use Conda. I don't know if they mean, because I'm not familiar with the Python stack a lot, but I don't know if they mean it's this Anaconda thing or so Python Conda. Let me just search for this Conda. Maybe I'll install that. Maybe that makes sense. Conda build. Installing and update a Conda build. Conda build contains commands and tools to use Conda to build your own packages, blah blah blah. But I want to install, so install Conda Ubuntu. Anaconda Python distribution. I don't know if I have that already here or not. I don't know. Can I buy a script? Really? Okay, let's try to do that. Retrieve the latest version. Accept. Python. What Python version do I have? Python version. Does this work? 2.7. Then let's download this one. And then we are going to step 2 while this is downloading a kind of bash script. Move into the temp directory and use curl to download the, okay. So I'll go to the temp and basically paste this thing. So good, verified data integrity. We're going to skip that. Run the Anaconda script. Run the Anaconda script. Complete the installation process. Oh, I'm so stupid. Why am I downloading that? Copy the bash script. Eh? Command line installer. Find the latest version and copy the installer bash script. Okay, I don't know, I just downloaded this one. Maybe it just works. Let's see. The download was not needed. What am I doing? And now basically paste and then enter and then yeah. Can I just get to the end? No. Yes or no? Yes. Anaconda will not be installed in this location. The Anaconda. Okay. Yeah. Okay. And so what is happening now? Is it doing something or it's installing? Hmm. Yay! Nice. Okay. I hope it doesn't take long. If not, I'll just um, cut the video so you guys don't have to go through or wait for that. And what else here? Installation finished. Finished. You should install to prepend install location. Probably will go for yes. And then activate the installation. This. And then conda list. Okay, so okay. Good. So while this is going on, while this is installing, let me go back to the repo. So I guess this is just like they've got the requirements here, and the pip just will take care of installing that stuff, and then you can run that, which is an example, and then if you are on Unix systems, you can give executable permissions to submarine and run. Okay, so you first probably gotta give them execution permissions, and then okay, you can just run it like that. Okay, you can. You don't have to. And that's it, really. Okay, how's it going? Installing. Um, let's take a look at the code while this is going on. So let's see, what are the requirements though? I'm curious. Okay, yeah, NumPy, a bunch of other stuff. Again, I'm not really familiar with Python, so I'm like a total noob. And I haven't, despite the fact that I've been, I've done development in the past professionally, but I haven't really touched code for a while, as I've been more involved in product management and stuff like that, and more kind of like the scripting type of code of coding. Um, do, 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 do. What I want to do, I want to take a look at the code. So this is still installing. So there's an example, which is what we're going to run. And then but let's take a look at the example, because then the maxcat solver is really okay. So I'll have to refresh a little bit my mind, I think, but if I remember well, because Mihao got in touch with me and he basically shared a couple of places where I could take a look about, to learn a bit more about the maxcat problem. Actually, let me see if I can find that. So I found it. And actually, at the same time, this is finished. If I take a look at here, now it tells me to check. No, to activate the installation. Okay. Paste. Then conda list. Oh, come on. Things for installing a conda 3. Maybe just need a new. So this is command not found. Okay, that's awesome. Maybe I should just use the. I just realized I downloaded the Mac OS installer. um, so maybe I'll just download this and get going. Maybe I can just skip the Anaconda and just go ahead. Maybe the requirements thing should maybe get everything that I need, probably. the via PEEP, I guess. It's not. So that is in where is that now? So now this is probably in da, 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 somewhere in like this is probably in downloads. This is probably in downloads. Is it? Yeah, Linux. Okay, so maybe I just like I'll just maybe move that. So move Anaconda Linux to whenever. I just I'll just do sh on that Anaconda. Yeah. So I just did that, and I hope that's not gonna now just create more conflicts. Say yes, yes, Anaconda 2, yes. Okay, that's awesome. Ba-ba-da-ba-da-ba-da. Cool. Unpacking. So let's just go ahead with again what I was trying to do, right? So I'm here. Okay, no, let's read. Let's read that. Let's go through that a little bit. If it just okay, perfect. So quantum approximate optimization algorithm. This is basically Michał shared this link with me and said, this is kind of like a guide on how to approach optimization problems, and it goes through the MaxCat problem, which is exactly what the Yellow Submarine project is about. So I thought it would be interesting to just go through that and see if it was anyhow helpful. Like the most prominent algorithms in quantum computing in the last few years. Okay, so it's about QAOA. How to use PyQuil, Python platform for quantum computing, how to solve MaxCat problem using QAOA implementation in PyQuil. What does it mean in practice? What does it mean in practice? That quantum computing is probabilistic. Basic information about QAOA works. Okay, that sounds interesting. Prerequisite. Oh, this is scrolling so slow. I'm having. Maybe I gotta do something with the virtual machine setup because this is going so slow. Before we can go, I should prepare a couple of things. Configure Forest API key, install PyQuil, learn the basics of quantum computing. That's a good one. It's like, good that you want to start, install stuff, and then just learn the basics. That's a good one. It just takes anyway. I recommend going through the PyQuil documentation. You can also check out this tutorial by the guys from Protein Cure. It was designed for the workshops, not self-learning, but there are many hands-on exercises. Okay, maybe I'll use some of those things later on and do some videos about it. Even though I try to make this tutorial as accessible to the non-quantum computing people as possible, you probably need some level of familiarity with the following concepts: qubits, quantum gates, superposition, entanglement. Yeah, we got all of that, I guess. I hope. You don't need to go very in depth. I think spending about 30 minutes with the PyQuil docs should be enough for the beginning. Terminology. Okay, the bracket stuff. I try to use as easy language as possible, and by easy I don't mean very specific, neither for physicists, programmers, nor quantum computing people, but sometimes it's just not possible. So here we'll try to explain some of the important concepts. Operator, blah blah blah. It's a fancy name for a matrix. Okay, Hamiltonian is an operator describing the quantum system. Its eigenvalues represent the energy values that the system can have. Pauli matrix is one of the three 2x2 matrices commonly used in quantum computing. The X gate, the Y gate, the Z gate. It flips Ket0, Ket1, Ket0 and 2. Okay. Yeah. Then, okay, so we know all the basics. QAOA. It's pretty loud outside. I hope that it's not bothering you guys. Let's just close the window. It's better. Better. Some coffee. Mm, QAOA is an algorithm for solving a broad range of optimization problems using NISC devices. Straight to the TSP will solve. Let's start easy, and instead of going straight to the TSP, we will solve MaxCat problem. This part is based on Righetti's tutorial on QA on so Righetti has its own tutorial on that. Okay, but that's the remember that I had a bit of trouble understanding the actual MaxCat problem. Wait a second, is this done? Kind of seems like. Yeah, but it's still, yeah, whatever. If you prefer, okay, so to install conda shell functions. Oh, wait a second. Do you wish to install it to initialize an conda by running conda init? Yes, no. You have chosen not. Why? Conda based environment in your current shell session. To install conda shell functions for easier access, first activate. How do I activate that? Okay, but maybe we don't need those things. I just wanted to basically quantum intuition, cd quantum intuition. So I just basically want to. I have Git, right? I have Git. So basically, I want to clone. Before we go through that, I want to clone that. Yellow submarine. Clone or download. So git clone paste. Good. So that should get us the project. That should get us the project in our file system. 70%. Good. So let's go. Let's see. I just want to wait. Okay. So do we have this? Yeah, yellow submarine, and then we've got all the stuff here. Perfect. Maybe I'll just let it. While reading that, I'm just trying to parallelize some stuff so you guys don't get bored. We'll just see if. Okay, so I'm just gonna go in here, and now I'm gonna run this. Sorry. Oh, come on. txt. Okay, so while this is installing all this stuff, let's go ahead. So the MaxCat problem starts with a graph, and we want to divide it in two subgraphs in such a way that the edges between them would have the highest possible sum. Okay, so we've got a graph, and I want to split it in a way that the edges between the two parts of the graph would have the highest possible sum. It's pretty abstract, but let's take a look at an example. We'll color the nodes blue and red to distinguish which group they fall. Is a graph with two nodes, right? So we can color it the following ways. Yeah, good. Cost 0, cost 1. Okay, so here in this case, it's like okay, so it's basically it's counting the edges between the two groups. Little more advanced example. Okay. So okay, I get it. To understand it better, I recommend drawing a 4-node graph on a paper and try to solve it by hand. If you still don't get it, check out these sections. Okay, now I get it, I think. Yeah, it's kind of just, it's still a bit abstract, so I don't know. I mean, but maybe it's just the way it is. It doesn't have to have any practical mapping right now. It probably has a lot of problems that you can reduce them to this particular problem, but that's the idea, right? So split the graph in two groups in such a way that the amount of edges between the two groups is the highest. QAOA solves MaxCat Okay, so this algorithm QAOA solves MaxCat. That's the idea. Okay, so let's take a graph with our with 4 nodes. We encode it as a list of tuples, where each tuple represents an edge between given nodes. Okay, so that's how we encode it: 0, 1, 0, 2, 0, 3. So there are 3 edges. This is again is node 0 because then it goes through all of them. Okay, the optimal solution for this graph is either 1, 0, 0, 0 or 0, 1, 1, 1. But what do those represent? Like, does each of these represent a node? Let's try to solve the MaxCat problem for this graph using MaxCat solver from the Growth library. Hey, keep in mind that the runtime is non-deterministic. It should finish running under a minute, but sometimes it takes longer. Interesting. So MaxCat solver, get angles, betas and gammas can run the actual program. Don't worry about understanding what betas and gammas are for now. Qubits. Okay. Now that we have the values of betas and gammas, max get angles. Okay. So this is, yeah, it's like, okay, I don't know. QAOA. Now that we have the values of the betas and gammas, we can don't worry about understanding what betas and gammas are for now. We will get back to it later. So then there's like NP is numpy, okay. H stack, betas and gammas, angles, paramproc, parameterized program, angles, qubits. So declaring 4 qubits, use 4 qubits, these, and then try 1,000 times. Okay, run a measure. So this seems to be the part that's doing the actual running whatever quantum circuit. And then okay, so and those are the, okay, so 4 qubits. Those are the, I guess it's using 1 qubit per edge, per node, which would be the angle kind of, right, between 2 edges. And so this, it seems like the output is sort of, you've got all the possibilities, all the possible combinations, and then you've got the probability of, I don't know, it seems like that's what's happening. So it's kind of, as you can see here, those are the most frequent answers. That's also what the solution was according to Michał here. The two most optimal solutions. Okay, so why? Finding the right angles. We initialize the MaxCat object with our graph. The QAOA algorithm tries to find the optimal values of betas and gammas. The optimal values of betas and gammas. But, yeah, but what is that? What is that? This time we have not suppressed the output, and with every iteration of the algorithm, you can see 2 lines being printed. The first one is the parameters, these values of betas and gammas. The second one is the cost value. Maybe the betas and gammas are parameters for the circuit. So just had to pause for a second. I'm not so sure if you're going to hear the audio differently right now. I hope it's going to be a bit better, but I think I was having some troubles. Okay, good. So it seems like those are simply the parameters maybe that the circuit is parameterized with, and then the algorithm is kind of trying different things and then seeing the cost function and minimizing the cost function. I think that's kind of intuitively what's happening here. Exactly. So create an array with angles with correct. Okay, we take a template for quill program. We take a template for quill program from the MaxCAD solver. We initialize this problem with the angles we have found. Print prog. So prog is the circuit, I guess. Okay, I see. So you see here, there's like one parameter. Here's another it's probably, yeah, that's probably half of the gamma, half of the gamma, and then this 1 point something, it's maybe used somewhere else. I don't know. 37. Okay, so it kind of has it's kind of basically it's a circuit. It's a quantum circuit that's based on the actual graph, I assume. But then how is that constructed is still sort of a black box to me. And then by just parameterizing that and running different things and making different runs with different parameters, then we just learn. I mean, that's classical. Okay, it's classical kind of a classical learning approach to that sense. Probabilistic nature of quantum computing. We know about the probabilistic nature. Yeah. Change the state of the system. Okay, probability for all possible states. Okay. Yeah. I mean, that's kind of like, so Miha, I think that's really nicely written, especially for someone who doesn't have any basic knowledge on quantum computing. It might be a bit harsh at the beginning to go through all those concepts here, but I mean, I understand what you're trying to do here. I think it's good. System system are very easy to interpret. Calculate the actual probabilities based on these. Okay. Yeah. And those are the probabilities. Okay. Yeah. So exactly. So and those are then the two. Nice. Okay. So how does this work? Is this done? Could not find versions to raise requirements. Okay, but it's matplotlib. Maybe we don't need that anyway. Can I run the example? What was the Python yellow submarine example to Py? So we've got the, okay, so Python yellow submarine example.py. Syntax error. File in line 12 in Maxdata import Maxdata parameterized gate file non-ASCII character in file. Okay. Do I have a text editor in here, or do I have like Jedit or something? Yeah. Open. No. Where am I? Home, quantum intuition, yellow submarine, example Py. Slide. Can I view the lines? Non-ASCII character. I mean, what is this? XC5? Non-ASCII character. XC5. Maybe it's something with the versions. When your code is trying to use ASCII encoding, but the pound symbol is not an ASCII character, try using UDF-8 encoding. You can start by putting these at the top of your Python file. Yeah, it's there. It's there. Worked for me. First line was necessary. Yeah. I got the same problem in my Python after adding it resolved the problem. Code data. Or use the magic available since Python 2.6 to make it automatic. Oh, I guess that's what's breaking. Michał, your name is breaking stuff, is it? Can I just remove his name? Sorry, Michał. Maybe that works. Maybe that works. Maybe that works. No, it's still the same. What is this character though? What is this character? XC5. XC5. Yeah, it's his it's his name. It's a Maxcat solver, of course. Okay. So it's like paste. Oh, come on. Can I not just copy, edit, paste? Meow. I'm just lazy. I know I could probably fix it another way. I just don't want to. I hope there's nothing else anywhere in here. So let's see if line 9. What is now the problem? No module name, strawberry fields decompositions, import error. Then maybe something's missing in the requirements. If I do that again. So here, if I do that again, LS, yellow submarine. And if I now do install requirements.txt, exactly, because that should give me the, but something's breaking in here, maybe. Gedit requirements txt matplotlib. Yeah, and then it just stops. Okay, what if I just get rid of matplotlib? I hope I'm not breaking the stuff here. So what am I doing? What am I doing? Close this terminal, install the requirements, see what happens. Really, I just want to run the example. I mean, that's probably going to be everything we can do in this episode, not to keep it too long. But it seems to be what I initially if I remember well the very first video, that's what I was suspecting. That's like you build a circuit out of a graph, and then you basically, it's a parameterized circuit, and then you find the really no matching distribution found for strawberry fields. Strawberry fields. Copy. Strawberry fields. Ba, 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 da, ba. Maybe pip install strawberry fields. Paste. Failed. Okay. So I think there's just something wrong with my Python stuff in here, and I'll probably try to fix it, and then kind of get the example running. But it's basically okay. So how QAOA works? Black box approach. The easiest way to look at this is think about inputs and outputs. To solve the max problem, the only thing we need was the graph, which we passed to the instance class. Class is a little more advanced version of the following line. Connection. Qubits are the same qubits that we used earlier. Steps is an integer. Cost ham, ref ham, init gammas, init betas. Minimize the KW arcs. How to encode our problem. This is the, okay, so this is where it starts. Okay. So, but I think it's been enough for now. So I'll just stop here. It's really about encoding the problem. That's where we're going to start in the next video, and then I'm going to try to get that other stuff running, see what was wrong with the Python. It's probably the Python stuff, but I see here it's okay. So here there's an explanation. That's going to be definitely helpful. Perfect. So we'll take a look at these in the next video, and I hope you guys enjoy the project review. Cool.